Last week I gave a fire safety talk, and nobody paid any attention. It's my own fault for using PowerPoint. PowerPoint is boring. People learn in lots of different ways, but experience is the best teacher. Today, smoking is going to save lives. CHEM!
Oh my god! Oh my god!
Fire!
Oh, fire! Oh my goodness! What's the procedure? What do we do, people?
Potential building fire. How could the cigarette from Dwight cause the building to catch fire in this office episode? First, flamed ignition needs to take place. Fire starts by heating a combustible source, e.g. one that contains carbon, to its ignition temperature, the thermal point at which a material will burn via energy. In this case, the lighter fluid from the lighter is exposed to enough kinetic energy to raise the lighter fluid to its ignition temperature, giving us the flame. The thrown cigarette then makes contact and heats paper in the trash can to its ignition temperature, and since fire is a combustion chain reaction, the fire continues to burn more combustive material around it until there is no more inflammable material to burn. Thus, a building can burn down via this chain reaction by being a combustive fuel source for a fire once it spreads from its original point. Properties of smoke. Smoke is the primary byproduct of combusting material because of incomplete combustion via insufficient oxygen supply. But because the materials are being heated to their ignition point, the uncombusted compounds vaporize or sublimate. Smoke is the condensed gases produced when materials burn along with smaller solid and liquid particles in its composition. Usually hydrocarbons, aldehydes, and acids form most of the composition of smoke from burning paper. Smoke's visibility depends on this, with denser gases and higher concentrations of solid and liquid particles producing thicker, more visible smoke, and the opposite producing less visible smoke. Pam is able to see the smoke because several compounds from it are visible, such as the carbon, usually soot, ash, oils, and tar. With paper, it's mostly ash and soot that's seen.
Are dead!
Oh, how did that happen?
It's out in the hall!
No, we don't know that. The smoke could be coming through an air duct.
Oh my God! Okay, it's happening. Everybody stay calm.
What's the
Everybody
procedure,
stay calm.
everyone? What's the procedure?
Stay calm!
Wait.
Everybody calm down!
No, Michael, no! Touch the handle. If it's hot, there could be a fire in the hallway.
What does warm mean?
Oh my gosh, try the other door.
Not a viable option. What next?
Go to the other door.
Oh, here's a door. Check that one out. How's the handle?
It's warm. Okay, go to the back
Well,
door.
another option. Jeez, okay, settle down, everyone. No
I
tension.
forgot my purse!
Leave it, woman!
Get out of the way. Go.
No, things can be replaced, Phyllis. People, human lives, however, can...
Ah, my hand. That's hot.
In the episode Stress Relief of the Office, it opens on Dwight starting a fire and heating doorknobs in an attempt to fake a realistic fire. When a makeshift fire has begun, why does Dwight tell them to feel the doorknobs to see if that door is the safe exit? I'm going to look at the chemistry to explain as to why he did that. This is the most reliable single indicator of a fire threat. Metal doorknobs are typically used in most types of doors. They provide constant, relatively high thermal conductivity, as well as diffusivity paths for conductive heat transfer for a possible fire environment, as well as the protected space. Within almost a minute from the time of a full fire exposure at the doorknob is the source where we can easily detect elevated temperature. However, as effective as this method may be, it is important to remember that a cold doorknob does not mean that there is no fire.
Fire can be extremely dangerous and deadly, especially when confined in an area such as an office building. When a fire occurs, it can spread by doubling its size in seconds. In as little as 30 seconds, fire can rage out of control, filling a room with heat that ranges from 100 degrees at floor level to 1200 or more degrees at the ceiling, all while producing toxic thick smoke. Your skin can burn with permanent injuries at 160 degrees, and if you inhale the superheated air, it can scorch your lungs.
Exit points, people. What's next? Huh?
Stay alive. I'm getting help.
Pull me up!
You're too heavy.
I only weigh 82 pounds! Save Bandit!
How about 911? Anyone? 911.
What do we do?
In the episode, we see how people react to life-threatening situations such as fires. The fight-or-flight response is a subconscious survival instinct. The fight-or-flight response happens independently of conscious thought. In an emergency, your autonomic nervous system takes over and spreads the message all over your body to get ready to survive however it can. Epinephrine and norepinephrine are transmitters that are released from your adrenal glands and prepare the body for fight or flight. Norepinephrine, an organic chemical synthesized in the brain and adrenal medulla, increases alertness, enhances formation and retrieval of memories, and focuses attention. Epinephrine is released directly into the bloodstream from the adrenal glands to provide energy to the major muscle groups so that the body can respond to the threat.
Oh my God!
Attention! Employees of Dunder Mifflin! This has been a test of our emergency preparedness. There is no fire, it was only a simulation.
What?
Fire, not real, this was merely a training exercise. So, what have we learned? Oh, come on, it's not real, Stanley. Don't have a heart attack.
No. You will not die. Stanley, you will not die. Stanley.
There are many chemical effects of smoke on the body. Smoke contains various chemicals including aldehydes, acid gases, sulfur dioxide, nitrogen oxides, benzene, toluene, stearine, metals, and dioxins. However, the main acting agents in smoke that can cause damage to the body and the organs are carbon monoxide and small particles. Short-term exposure can be damaging to the body, causing things such as unconsciousness due to the lack of oxygen that your body is receiving, loss of sight, and major headaches that can last for days. Long-term effects can include asthma, heart and lung disease, and in worse situations, cancer and death. In 2014, there were nearly 3,300 deaths from fires in the United States, and there were nearly 1,300,000 fires in the United States.